Continuing lesson 4.2 on equivalent expressions. So we have a question here. Are these equivalent expressions? Use substitution to justify your work. So first of all, to see if they're equivalent expressions, probably the best way of doing that is to try to simplify these expressions. If these expressions simplify to the same thing as each other, they are equivalent expressions. If they don't simplify to the same things, then they are not equivalent expressions. It does also say they want us to use substitution to justify. So what we're going to do, we're going to simplify, see if they simplify to the same thing, and then we will do what they asked us to do and substitute a number, a random number in to what we had originally, and just verify that we actually get the same number in both cases. So on our first expression, we can distribute here, distributive property we talked about. So we do 2 times x minus 2 times 3. The plus 1 will just bring down. 2 times x is 2x. 2 times 3 is 6. What we have to remember here is this is 2x minus 6 plus 1. It's been a while since we've combined like terms and stuff, but if you add the opposite, that is like a negative 6. So we can combine these together. If you combine these together, negative 6 plus 1, like if you owe $6 and you pay back $1, you're going to still owe $5. So you could say that is plus negative 5, or that's the same as minus 5. So 2x plus negative 5 or 2x minus 5 would be our expression there. If you look at your second expression, 2x plus 6, those are not like terms, so that one's already simplified. So the question is now for us to look at these and see if they're the same or not. If they're the same, they're equivalent expressions. If not, they are not equivalent expressions, and these are not the same. So we could say no. Probably would want to write something out saying no, they are not equivalent expressions. And then the other thing, they ask us to use substitution to justify that. So for substitution, we can pick any number. I would probably pick something reasonable, and we're going to actually substitute it back into the original expression just to prove that these are not equivalent expressions. So if we put a 5 in place of x, order of operations, if we do the parentheses, 5 minus 3 is 2, and then we could do 2 times 2 is 4, 4 plus 1 is 5. So we put a 5 in and we got 5, interestingly. On our other expression, if you put a 5 in place of the x, 2 times 5 is 10, plus 6 is 16. Okay, so what should happen if these are equivalent expressions, whatever number we put in, we should get the same value. This one, we did not get the same value, and pretty much anything we put in, really anything we put in place of x, these are never going to be the same. So don't think it was just a magical number that I picked 5 and it worked, or it didn't work, I should say. Whatever number you pick, these are not going to be the same answers when we substitute that in. For this problem, if the only thing they're asking if they are equivalent or not, technically we could just substitute, see if we get the same value or not, and that would tell us if it's equivalent or not. Sometimes they might ask you to simplify them as well, but technically if they don't do that, if they just ask if they're equivalent, a way around that would be substituting a number in and see if you get the same answer rather than simplifying them like we did first on this problem. So on page 197 in your book, example 3 asks which of the expressions below are equivalent to negative 2/3 x minus 2. So negative 2/3 x minus 2. If you look at the first expression, basically if you think about what we had to start with here, and if you would take that and just add the opposite there, that's the same as negative 2/3 x plus negative 2, and so that is exactly equivalent. The second expression, we have 2 minus 2/3 x. Well, 2 minus 2/3 x. You could switch it around if you wanted to. You could add the opposite here and then switch it around. And then that would be like negative 2/3 x plus 2. Okay? Subtraction, we can't switch the order. Addition, we can. So if we add the opposite, then we can change the order. And then we can see the one here is a plus 2. Up here it was plus a negative 2. So those are not the same, not equivalent. And then the third one, we've got kind of a mess going here. So we have some like terms we can combine. Negative x plus 1/3 x. Remember, if there's not a number in front of the x, we can put a 1 there. So that's like negative 1x plus 1/3 x. Negative 1 plus 1/3. We have more negatives than positives. So basically we're subtracting those. So if you have 1 and you take away a third, you're going to have 2/3 left. In this case we had more negatives, so that's a negative 2/3 x. Negative 2/3 x plus negative 2, and that's what we had exactly, so that one actually is equivalent as well. So on the try it, they want us to write two expressions that are equivalent to negative 5/4 x minus 3/4. There are an infinite number of possible answers here, technically, that we could come up with. Some that will be a little bit easier for us to come up with than others. So a few options here. One option would be technically we could just take what we've started with here. They're subtracting. If you add the opposite, technically that is slightly different, and that would be an equivalent expression. Okay? We have to be careful doing this. Another option would be switching these around. You probably would want to maybe add the opposite first before you do that, and so maybe even saying negative 3/4 plus negative 5/4 x. Okay, just switching the order technically is an equivalent expression. We could change these to decimals, so negative 1.25 x minus 75 hundredths. That would be another example. We could have things where fractions are not reduced. So we could have like negative 10/8 x minus 6/8 would be one option there. Even if just one of the fractions is not reduced, technically that would be equivalent. We could get more creative and have separate terms that we could combine. So like for example, negative 1/4 x plus negative 4/4 x minus 3/4, okay, to where if you combine those x terms would give you the negative 5/4 x. All right, and like I said, technically there are an infinite number of possible answers that we could give that would be equivalent to that. So if we look at the do you know how number 4, they are asking us to write an expression equivalent to this. When you do these, as you guys move on in math, it's going to be beneficial for you learning how to combine like terms in order to solve equations and stuff. You'll get into more with algebra. So my suggestion that I would like to see you guys do here, writing an expression equivalent to this, would be to actually simplify this as much as you can. Okay, so write an expression equivalent to this. It's not simplified, unlike our last problem. So let's just try to simplify it to get some practice on that. In order to go to simplify this, if you notice, we have some subtraction happening in the problem. Anytime there's subtraction, I would suggest you go ahead and add the opposite there. Make your two sign changes, add the opposite. So change subtraction to addition and then do the opposite. Okay, so minus 4 is the same as plus negative 4. Minus 1/3 y is the same as plus negative 1/3 y. And now we can start looking for like terms that we can combine together. So on this problem, I usually like to start with the variables first. When you look at these, make sure you include the sign to the left of it. Okay, and like I said, if they're subtracting, add the opposite first. So we've got 2/3 y plus negative 1/3 y. So these are different signs, so we're going to take the difference of those. Basically, it's 2/3 minus 1/3 would be 1/3. We had more positives than negatives, so our answer is going to be positive here. So that'd be 1/3 y. And then negative 3 plus negative 4, those guys are working together. Negative 3 plus negative 4 would be negative 7. So 1/3 y plus negative 7, that's the same as 1/3 y minus 7, if you want to write it that way. Those would be my suggested answers that you give for this problem, because that gives us some practice on actually simplifying expressions, which is really what's going to benefit you down the road in math.
But you could.
One other way of writing this, I started it out with the variable, but if you didn't do it that way, negative 7 plus 1/3 y would be another equivalent expression that's also simplified. So one of those three answers, that would be my preferred answer that I'd like to see you come up with there. So if we skip down to number 6, they want us to use the properties of operations to write an expression equivalent to 4x plus 1/2 plus 2x minus 3. And once again, our equivalent expression means we're going to simplify this again. Okay, we're going to simplify this expression as much as we can, because that's ultimately what's going to benefit you guys the most in math as you go along. So one thing on this problem, looking for like terms, we've got a 4x and a 2x we can combine. It's 4x plus 2x, so everything's looking positive there, and so that would be 6x. One thing we might have wanted to do here before we got going, on that last part they're subtracting, so you can go ahead and add the opposite there. If you didn't do that right at the get-go, that's okay, but you probably want to do it before you try to combine these constants together. So we've got a 1/2 plus a negative 3. If it helps you, if you want to rewrite them next to each other, you're welcome to do that. These are different signs, so they are going to be working against each other, so that means we're going to subtract them. So you could probably just think about this. Imagine if you have 3 and you take away a 1/2, okay? It means you're going to have 2.5 left, okay? You technically can borrow and get 2 halves and subtract, but you guys can probably get by without that step. It's 2.5. We had more that were negatives than positives, so the negatives are going to win out in this battle. And so that means we have 6x plus negative 2.5, or you could write it as 6x minus 2.5. Okay, if you notice that bottom expression, if you add the opposite, you'll get plus negative 2.5 just the same. Again, if you had it switched around, negative 2.5 plus 6x would be fine also. So when you're doing these problems and it asks you to write an equivalent expression, I would like you to first look to distribute. In other words, use the distributive property if there's something outside of the parentheses, like if you have a 3 times the quantity x minus 2 or something like that. we can distribute. Other thing is combining like terms, okay? You may or may not have to distribute first, but then after that point, trying to combine the like terms together to get that equivalent expression. If neither of these is an option, if it's already simplified as it is, then you could just add the opposite or change the order if they're adding to come up with an equivalent expression. But these are the things I'd like you to do first because those will be the most beneficial for you in math.